In this video we're going to look at connecting your Arduino to the internet, and we're going to use two methods in this video. We're going to use processing to utilize the internet connection of your host computer, so that could be your PC or your Mac or a Raspberry Pi, and then we're going to use an Ethernet breakout. Now you can get Ethernet shields and you can get Wi-Fi shields, but for now I'm just going to show you one particular Ethernet add-on, and then you can look into the wireless options later in the course. So as I said, first we're going to use processing. So this is the Arduino side, and simply send in serial again. We're going to say wait until the processing application is ready, and then send the value that we're reading on the analog pin, and in this case it's A0, so pretty much similar to what we've done before. Now we're only going to do it on startup just because we don't want to bombard the service we're using too much, and that service is IFTTT. You can see I've got an applet on IFTTT which checks for if we contact it using the webhooks, and then it'll go to my Dropbox and append the values to a text file. I did have this running and sending me tweets, and I very quickly got to the 100 cap that they have on a daily basis. So better to test with something like Dropbox where they're not going to limit you too much. Let's have a look at the processing side. Obviously this isn't the real code that they gave me, the real key. That's because it's like a password and you want to keep it to yourself, so don't share it with anybody, don't upload your code anywhere that somebody's going to see your API key. And like before, it's going to read the serial connection, but the special thing that it is going to do is once it's read the data that we send it over serial, and then it's going to use this function called load strings, which goes to a web URL and uses the IFTTT trigger that they gave me when I set up my application. So you'll be able to find it in your own settings. I can't show you it because it'll show you my API key. And then whatever we get back as a response, we output to the console just to make sure that it's worked. So let's see that working. It'll be easier to understand. So I'll simulate it just for now. So I'll put in ready, and it'll send back the value that it's getting back from the analog. So I'll close this down and go back to processing. So now it's saying it's ready, and if I now show the screen, it says congratulations, you fired the Arduino event, and this is the data that it's just got back from the analog pin. And if I reset, this time it's got 478. The second example is a web server, and obviously your Arduino is not going to be a web server in the traditional sense of serving hundreds of people an e-commerce website. No, we can use it though for communicating between your phone, your tablet, other devices over the internet. So just because this is plugged into Ethernet doesn't mean that you can't communicate with it using Wi-Fi. only the Arduino's tethered. And it uses a library called UIP Ethernet. This is pretty much the same as the official Arduino shield syntax, but these cheap eBay Ethernet devices work with a different chip, and so we have to use this library instead. It sets up a dummy MAC address because you're connected to the network, you need the MAC address, and it starts the server on port 80, which is the unsecure web port. So it's not using SSL, it's just basic web. And as a simple example, I'm making a counter. Every time you do a request, it increments the counter. Once it's got a connection to the network and it's got an IP address, it displays the IP address in the serial monitor, and then it waits to be contacted by a client, i.e. a web browser. If it's got a new connection, it'll output that, and then it looks to see if a carriage returner for a new line is sent on its own, which means it's the end of the request. Until that point, it keeps loading up a string with the latest character that's been sent, because we need to get all the communication that's been sent and then see what they're asking for. And because it's a web server, I decided to go beyond the usual examples, which is just hello world, and say if they've asked for /test, which is a web page called /test, then send how many requests have been made. So this could be a temperature reading, it could be how many people have passed through a door, anything like that. It's just examples showing an incremental number or you sharing data over this web page. And it does that by checking the index of the text we were looking for. So that's the position in the string that we've been building up. So if it wasn't found, it would be -1. It means nothing. It's not being found in that check. But if it is found, it'll give the position, the character position in the string. So we know if it's more than -1, it has been found, so we can give them the special web page. Otherwise, we just give them the basic home page, which is hello and welcome. Then we do a small delay and we say responded. So let's have a look at this now. And I'll open my browser here so that we can see it working. So it's booted and I've got the IP address 10.0.1.18, and I'll refresh this. So this is the behind the scenes request that it's making, and it's making the request to the IP address. It's got some cache control, that's your web cache. I'm using a Mac, using Chrome, and I'm asking for HTML, and that's the first request. And then, as you can see, it makes 2 requests. It asks for the favorite icon, the little icon that appears up here in the tabs. It's asking for one of those. It's not going to find it, but that's made it 2 requests. So if I now go to /test, it says there's been 3 requests because I asked for /test, which is 1 request, and if you remember, there was the homepage request and the fave icon request. So that just shows we can output data and we can interact across the internet. Now, obviously, this isn't going to respond across the internet without making it accessible to the outside world, and I would caution you to be careful about doing that. So right now, it'll only work on my local network. The last example in this video is we're going to do a HTTP request. So the last one was a server. This one is going to do a request. And what we're actually going to do is we're going to log data at thingspeak.com. So ThingSpeak is a service for the Internet of Things that allows you to create a number of channels and write data to them over the internet. And this is my channel setting, so I've just called it logging. It's my login data test, and I've got one field. And if you look at this page, you'll see that it's actually making a graph of the data that I've sent it. And again, I'm just sending it the value of A0. So you can use this to do lots of different visualizations and such, or you can just get back the raw data. So this is the raw data back, and this is the last request I made, and you can see it's got the value 619 in the field 1, and that's again the value on that analog pin. So what we're doing is we're setting up a pin, A0, again a dummy MAC address. We create an Ethernet client, and we output the IP address again. But this time we're saying this is the host we want to talk to, api.thingspeak.com. We connect to that server, again over port 80 because we're just doing an unsecure web request. We put the data that we get from the analog read into a string, and then if this was a real API key, which you again get from thingspeak.com, you'll have your own. We append the request with the data that we're sending them. It's talking to api.thingspeak.com, and then it closes the connection. All it's doing is sending that data and sending it away. If that didn't work, then we get connection failed. So let's have a look in the monitor. So it's got my IP address. This is what we get back from the server, and that has been output by the bytes that we get back, and it just keeps reading until we disconnect. Very simple examples, but you can see how you could use this for sending weather data to a central server. You could use it for aggregating security devices. If somebody trips a motion detector, for example, you could update IFTTT. You could get a text on your phone. So just think about how sending information out over the network or even the internet could be useful to you. Now in tomorrow's examples, we're going to look at how we can update our Arduino from the internet. So today we were sending information out into the world. Tomorrow we're going to get it back and act on it.